purpose of this video is to demonstrate the models I made as an outreach officer on the JR Expedition 327. One concept I learned was that the pipes can take much pulling, which is good because they can weigh some 50 tons per mile, but they break when pushed together. However, a drill requires a downward push to drill through the ocean floor rock. How can a string of pipes push down while they are being pulled up? The answer was to add weight to the bottom so that some of the weight would rest on the ocean floor and some would be supported by the ship. This would provide the needed force for drilling. In this model, if you watch the spring at the top, you can observe a shift in weight support. Complete a bottom-supported weight, removes the tension, and the pipes break. Another difference between drilling from a ship and drilling on land is that the ship is constantly moving up and down. This would add or subtract too much force to the drill. The solution was to add an air cushion between the ship and the supported pipes. In this model, you can see a balloon representing the compressed air. The outside can, representing the ship, is free to move up and down without changing the force of the drill. One topic scientists are studying is the water flow in the porous ocean rocks. The role this water plays in our water system is not well known. Here's one way of looking at water flow. One cup has a large hole, the other has a small hole. Water moves faster out one cup than the other. Also notice that as the pressure lessens, the flow lessens. If the cup was filled with sand, the water comes out very slowly. Water in the ground also moves slowly. As you can see from rocking this tube up and down, that the water level stays the same at both ends. However, if it has some sediment in there, there will be a delayed leveling. One experiment that is done on land is to measure the water flow in a tube with different pressures and sediment. In this model, the large sand-filled tube represents the subsea floor. You can watch what happens to the pressure as indicated by the water levels in the vertical tubes as they lift water supply bottles to different heights, which change the water pressure. Last summer, they placed a marker in the water in one hole. They will monitor to see when it shows up in an adjacent hole. Which brings up the next problem. We can't obviously be down there and watch for the marker to come to the next hole, especially if it takes years. In this egg model, the exposed membrane at the bottom allows water to move into the egg, causing the egg fluid to bulge at the top. Scientists use a similar process to siphon in ambient whole water at a controlled rate. They can collect water in small, very long tubes. It is hard to see here, but the dark water is moving up the tube. Knowing the rate of water crossing the membrane will establish the date of the water at different lengths in the tube. Finally, scientists want to study the bacteria down there. There is a well-established technology that aids in identifying the microbes down there. The model we have built will be shown in the upcoming workshop. I am amazed at the ingenuity of the science and the engineering. I have left so much untouched on the JR. Someone else will get to explore more. Participating in this expedition has increased my appreciation of model building. More importantly, it reminds me continually of the dedication and persistence of the JR scientists and all who live and work there, and how, in the end, they are victorious.